sklearnimputeSimpleImputer. Description: SimpleImputer is a class in scikit-learn that provides basic strategies for imputing missing values. In a dataset, it replaces missing values with a designated strategy, allowing for further analysis and model training. Inputs: X, a NumPy array or pandas data frame containing the dataset with missing values. Each row represents an instance, and each column represents a feature. Missing values: this parameter determines the values to be considered as missing. It can be a single value, a list of values, or none. To represent missing values as none, not a number. Outputs: Imputed, a NumPy array or pandas data frame containing the transformed dataset where missing values have been replaced based on the chosen strategy. The output data structure will match the input data structure NumPy array or pandas data frame. Steps: Fit: the SimpleImputer learns the imputation strategy from the data by fitting on the input data X. It calculates the values like mean, median, or most frequent to be used for imputation. Transform: the trained SimpleImputer is used to replace missing values in the input data X with the learned strategy. This step generates the imputed datasets. Imputed metrics: imputation accuracy: this metric measures the effectiveness of the imputation method. It can be assessed by comparing the imputed values with the original known values. Data distribution preservation: this metric measures how well the imputation method preserves the distribution of the data. It ensures that the imputed data doesn't introduce significant bias in the overall dataset. Distribution: visualization plots. Missing value heat map: a heat map visualizing the distribution of missing values across features in the original dataset. Feature distribution comparison: comparing the distribution of a feature before and after imputation to assess the impact of the imputation method on the data. Fine-tune parameters. Strategy: the imputation strategy to use. Choices include mean, median, most frequent, constant. Mean replaces missing values with the mean of the feature. Median with the median. Most frequent with the most frequent value. And constant with a specified constant value. Fill value when using the constant strategy. This parameter specifies the constant value to be used for imputation. Copy: a Boolean parameter determining whether to impute in place or create a copy of the data. Verbose: an integer parameter controlling the verbosity level during the fitting process. Uncertainty methods. Variance or standard deviation: the variance or standard deviation of the imputed feature can be used as a measure of uncertainty. This reflects the variability in the imputation process. Challenges and fixes. Challenge: 1. Missing values in a feature may not follow the same distribution as the observed values. This can lead to biased imputation and negatively affect downstream analysis. Sample use case: imputing missing values in a feature with a skewed distribution using the mean strategy may introduce bias, as the mean is influenced by outliers. Fixes: consider using more robust imputation strategies like median for skewed distributions, or use techniques like k-nearest neighbors (KNN) imputation. Challenge: 2. Imputing categorical features using most frequent can introduce bias if the most frequent category is not representative of the missing values. Sample use case: in a dataset with gender as a categorical feature. Imputing missing values with male most frequent category may misrepresent the actual distribution of genders. Fixes: use a strategy like constant to replace missing values with a specific category like unknown, reflecting the uncertainty in the missing values. Alternatively, consider using more advanced techniques like Bayesian imputation for categorical data.